In this video, we'll look at using physics forces. These forces will include ApplyImpulse and ApplyForce. Both of these forces can be used in conjunction with each other to apply quick bursts of force such as explosions or an acceleration of an object, taking into account the mass of those objects. So let's get started. Here we are in Visual Studio Code. So I have a class called Physics Forces. This class is somewhat similar to the class that we started off with when we looked at velocity. Now I am using ammo this time for the physics engine. There is a package you can install called ammojs-typed, and you can use this with BabylonJS. There is an ammojs plugin that we can use with BabylonJS as well. The process of utilizing ammo is nearly identical to Cannon, so we can use Cannon. There are some slight differences in the setup, but it's fairly easy to go over. In this class, I also have a variable at the very top. This is a mesh type for a cannonball. We're going to be shooting out a cannonball, and we're going to be applying forces to that cannonball. This cannonball here is essentially going to be the template for every time that we shoot out a cannonball, where they're going to reference this guy here. Now in the constructor, I have a method called createPhysics. This is going to be setting up all the physics elements. We're going to be tying in all our other methods into this method as well. So let's take a look at that real quick. And we'll close up this guy. So the create scene is similar as before. In the createPhysics, if we're using ammo, we need to set it up in this way. So we're using an asynchronous version of this. And I need to await ammo. And then we can pass this in similar to how we did this with Cannon. So we create a new ammojs plugin. And then we use that as a plugin for the enable physics. Again, I'm using the same gravity as before. So -9.81. Everything else is identical. Now, just to ensure that we don't have any issues with timing in regards to creating our physics or enabling our physics, I'm going to be calling all the physics methods in the createPhysics. Now, this is already being called in the constructor, so we'll be able to call these all at once. Okay, so in the createImpulsors, again, we have the ground that has a physics imposter, and that is set to isVisible is false. So that is the only physics element that we're starting off with. What we're going to be going over in this video is how to utilize impulses. We're going to be going over how to use ApplyImpulse and ApplyForce. Now on the surface, these seem very, very similar. The main difference between these two is that ApplyImpulse is going to be used for something like an explosion that allows us to apply a very quick force to an object, whereas ApplyForce is going to be used for something like a rocket. And both of these allow us to use the mass of the object. So the mass is going to be important. Whereas when we looked at the velocity of a rocket, it doesn't matter whether that rocket had a mass of 1 or 100. The velocity is not going to change. So let's get started with the impulse first. And for this, we're going to create a separate method called createImpulse. This will have a return type of void. And at the very top, we're going to create a box mesh. And we're also going to create a PBR material for this, just so we can actually see this in the world using the environment lighting that we have set up. So const box, this would be mesh builder dot create box. I'm going to call it box. Okay, now for the size, I'm going to start off with a size of 2, but we are going to be modifying this in a moment. We're going to be modifying its height, and I'll show you why once we get to that point. Okay, so we have a basic box. Let's also create a box material. So box mat will be equal to a new PBR material. Let's call it box mat here as well, and then add it to the scene. Now remember, with a PBR material, we need to ensure that we adjust the roughness. Otherwise, it'll be mirror smooth to start off. So I'm going to set that up to a value of 1. And then I also want to apply a new color to this. So box mat, that albedo color. And this will be a new color 3. And I want this to be orange. So I'm going to go with a value of 1 for the red, 0.5 for the green, and 0 for the blue. Make sure that we add that to the box. So box.material equals box mat. Okay, so we just created the mesh. Now we need to add a physics imposter to this. We've done this a few times before, so I am going to go fairly quickly through this. So box.physics imposter, new physics imposter, and then the object is going to be the box. And then we have physics imposter dot box imposter. And we're going to be applying a mass of 1. And just so this object doesn't actually slide around too much, I'm also going to increase the friction to 1. Okay, so now we have a box with a physics imposter. Now, what we're going to be doing is we're going to be applying an impulse to this box. And typically this is used for something like an explosion. I'm not going to be going through the process of creating all of that. Instead, what we're going to do to mimic the effect of an explosion is to left click on the box. And we can do that using an action. So when I left click on a box, I want to mimic the explosion affecting this box. So we're going to use an action manager for this. So box.actionManager. And we need to create a new instance of the action manager. Okay, we need to add it to the scene. And then we're going to register an action with this. So box.actionManager.register action. And the action that we're going to register is called execute code. So I'm going to say new execute code action. That takes in a trigger. So the trigger is going to be whenever we press a button on our mouse, whether that's left click, middle mouse, or right click. I'm going to say action manager dot, and let's look for the on pick down trigger. Next, we need to provide an action. So what is the actual code that we're going to be executing? I'll just use an arrow function for this. And the way that we're going to be applying an impulse to this is by referencing the box's physics imposter. I'm going to say box.physicsImposter.applyImpulse. You'll see that we also have ApplyForce. We're looking at ApplyImpulse right now. And both of these have the exact same parameters. So we have force and contact point. Now, force is essentially the direction that we're applying this force in. So we're going to start off with a new vector 3. And let's just say that we want this to pop up off the ground. So I want this to pop up and go vertically. We're going to say 0 for the x-axis, 1 for the y-axis, and then 0 for the z-axis. The contact point is essentially where we're applying the force to this object. For now, let's just say that we want to apply this directly at the center point of this object. We can say box dot, and then we're going to look for get absolute position. All right, so let's review this real quick. We're going to be using an action manager to allow us to left click or right click on this object. So if I left click on this object, I can then apply an impulse to the box, and we're applying that on the physics imposter. I want this to apply a force along the y-axis, and this is a positive value, so it'll pop up. And then we're using the center point of the box as the origin point of where this force is being applied to. Okay, let's make sure that we call this up above. So the create impulse is going to be called in the create physics. Okay, with this box, if I left click on it, you can see that we do have an action associated with this because you can see the cursor does change. When I left click on it, you can see it barely moves up. So it's essentially pulsing up just a little bit. And that's because the value of the y-axis that we set for the apply impulse has been set to a value of 1. So that's not nearly enough for this. Now remember, an impulse does take into account the mass of the object. So if the object was even heavier, we probably wouldn't even see anything at all. Let's take a look at playing around with the mass and the force that we're applying along the y-axis of this object. Going back into our create impulse, right now we have the mass set to 1. If I bring this down to say 0.5, it'll make it lighter. And let's also increase the amount of force we're applying along the y-axis here. So I'll bump that up to a value of 10. Okay, now if I left click on this, I can see it jump up, and you can see it goes up quite high. So we increase the force being applied to this, and we also decrease the mass. Okay, now we can use impulses to mimic the effect of an explosion. So what I want to do now in our code is if we had an explosion off to the right of this box, I would want this box to be affected and be pushed to the left. So I want the force to now change in this direction. So that would be a negative x-axis value. And I also want to increase the scale or the height of this object so that we can then change the origin point of where that's being hit. Right now, we're using the absolute position of this object, which is the center point. I want to hit it up a bit higher up. So we're going to increase its scale, and then we're going to push it over along the x-axis to the left. Let's take a look at how we can do that in our code. Okay, going back up to the very top of our create impulse, we're no longer going to be using the size. Let's go ahead and change this to height. So I'll set the height up to 4. And then because we are adjusting the height, I don't want this to get stuck in the center point of the world. So right after we create the box, let's also adjust its position. So I'll say box.position. And I just want to adjust the y-axis. I'll keep it at the center point. So let's go with a height of, let's go with 3. This will be above the ground, but with gravity, it will fall down. We'll keep the mass as is at 0.5. And down here for the vector 3, instead of using the y-axis, I'll set that to 0. I now want to move that to the left. So again, the explosion is on the right of us. It's going to be pushing our box to the left. So let's go with -3. That's not quite strong enough as before, but it is going to be noticeable when we do hit the box. Now for the absolute position, this is the center point. If you want to use the center point as the starting point of where that force is being applied, we can also use .add. This will basically add to the original point of our box. And for this is a vector 3. So I'll pass in a new vector 3. And here we provide basically a number that adds to the original vector 3 of the box. So I don't want to move this along the x-axis. I want to move this along the y-axis. So if we're at the center point right here for the y-axis, I can go up 2 units and then hit it up a bit higher up. So I'm going to say a value of 2. And then for the z-axis, we're going to go with the value of 0. All right, let's give this a quick try. Okay, so there is our box. As you can see, it's much higher up. Since we adjusted the absolute position to be up a bit higher, it should be up about right here. We're going to be applying a force in this area over here, which then will then push it off to the left. And because we're hitting it up a bit higher here above essentially the fulcrum of this object, it should topple over. So if I left click on it, there we go. So we're mimicking the effect of a force coming off from the right and pushing it over at the top portion of that cube. Okay, so now we understand how an impulse works. Let's take a look at using ApplyForce. And for this, we are going to be using our Cannonball. We need to create a Cannonball template. And then with that template, we're going to create a clone of it. And then we can use that to fire out a Cannonball every time I left click in my scene. Let's take a look at how we can do that next. Okay, going back into our code, let's go and close up the create impulse. We're going to create 2 separate methods. One is going to allow us to create the Cannonball itself. And then the second one will be used in conjunction with the scene. So let's start off with creating the Cannonball first. We're going to say create Cannonball. And this will return nothing. So we'll say void. And this will be nearly identical to how we created the impulse. So we're going to create a sphere, and then we're going to create the physics imposter with that sphere. Now, we already created a mesh at the very top called Cannonball. So we're just going to use that. I'm going to say this.cannonball. And we're going to say equals mesh builder.create. And we're going to go with a sphere. Call it Cannonball. And then for the diameter, I'll set this equal to 0.5. I don't want this to be too big or too small. Let's also create a material for this. So I'm just going to call it ball mat. And this will be a new PBR material. Now remember, with a PBR material, we need to ensure that we adjust the roughness. So I'm going to bring that roughness up to a value of 1. Also adjust the color of this. So ballmat.albedo color. And I'm just going to make this green. So I'm going to go with 0 for the red, 1 for the green, and 0 for the blue. Right? And let's make sure that we attach that to the Cannonball. Okay, we need to create the physics imposter. And we're using nearly identical settings as before. So a mass of 1 and friction of 1. So again, we're creating a physics imposter. This time we're using a sphere imposter, which matches the shape of our sphere. And then we're going to do something a little bit different with the Cannonball. Now with the Cannonball, when we're creating this, this is just a template. When we create a clone, I want to create a clone of this. But I don't want to have the original template visible in my scene. So what we can do is after we create the Cannonball, we can then disable it. I also want to make sure that the Cannonball is at the same position as the camera. So if we go back into our scene, my camera is at a Y value of 2. and -10 for the z-axis. We can use those same values. I can also just say this.cannonball.position equals this.camera.position, okay? And I want to do that before we actually turn it off. After we do that, I can then say this.cannonball.set enabled to false. We're creating the cannonball and then we're turning it off in our scene. When we create a clone of this, we're then going to re-enable that clone. So let's make sure that we call the create cannonball, and I'm going to do this in the create physics. Okay, so we created the cannonball template. Close that up. Now the second method we're going to be using with our scene. Whenever I left click on my scene, I then want to call this method. This method will then create a clone and then fire off that clone in the forward direction of that camera. So I'm going to call this shoot cannonball. The return type is also going to be void in here. And now what we're going to do is we're going to say const clone equals, and we need to create a clone of the cannonball. So that's going to be this.cannonball.clone. I'll give it a name of clone. And we can provide a new parent. In this case, I'm not. It'll default to null, which is fine. And then I'll say clone.position equals this.camera.position. And the reason why I'm doing this again is because I could move around with my camera. So I want to ensure that the clone starts off at the same point as our camera. And then from there, I can determine I want to fire off this clone. But before we can do that, we need to ensure that we can actually see our clone. So I'm going to say clone.setEnabled to true. Remember, we turned that off up here in the create cannonball. After we create the clone, then I set this to true. This is not turning on the original cannonball. This is a clone of that. So we want to enable the clone. After we do that, I then want to say clone.physicsImposter. And this time we're going to be using the ApplyForce. Okay, very similar to what we did with the impulse. So we're applying a force along a vector 3, and then we have a contact point. But the force that we're going to be using is going to be the direction of the camera, the forward direction of that camera. So I need to get the forward direction by saying this.camera. And if you type in forward, you should see get forward ray. Now we also need to pass in dot direction. So get forward ray dot direction. This is a vector 3 that will allow us to use this as the direction that we're applying the force in. Now after that, we also have a contact point. So in this case, with the clone, I'm going to use the center point of the clone as the contact point. So clone.getAbsolutePosition, just like before. Okay, so once again, just to review, whenever we left click in our scene, and we haven't set that up yet, but we're going to create a clone. That is a clone of the cannonball. We're then going to reset its position to wherever the camera is at. We could move around in our scene. Then I want to enable that clone. And then after that, we're then going to be applying a force to it. And the direction of that force is going to be wherever we're looking at with our camera. So if I look left and right, that is going to be the direction that we're going to be shooting this clone at. We're applying the force along the center point or the absolute position of where that clone is at. Okay, now let's go up to the constructor. I'm not going to do this in the create physics. Instead, I'll do this in the constructor itself. So in the constructor, right below where we create the physics, I then want to check to see if we're left clicking or right clicking in our scene. I'm going to say this.scene.onPointerDown. Now on pointer down is just checking for a specific button input from our mouse. If you take a look at the on pointer down, you can see we have EVT, which is the pointer event. I'll be using that to determine which button we're pressing on our mouse. So I'm just going to say E for short. And since we're using left click to look around in our scene, I don't want to be able to fire out a cannonball if I'm left clicking. Instead, I'll use the right click of my mouse. That way I can look around with my left click and then right click to shoot out a cannonball. So I'm going to check if E.button equals 2. So 2 is going to be right click, 1 is going to be middle mouse, and left click will be 0. So if we do press 2, if we detect that we're pressing 2, which is right click, I then want to call this .shoot cannonball. Okay, so let's give this a quick try. Let's see how this works. Okay, so if I right click and you can see, we basically just get a cannonball that appears at our feet. Now, why does this happen? Well, when we're using the direction of the camera, we're also using that as the force multiplier. And by default, that value is 1. So we're not really applying much, if any, force to the cannonball. So they just basically appear. They get created, but they don't have any force behind them. Let's go back into our code and let's modify that to add additional force to this. Okay, going back to our shoot cannonball, right here, this line needs to be modified. So with the direction, we can also add dot scale, and that's something that we looked at before. So with dot scale, we can essentially add a multiplier. And for these objects, we're going to start off with the value of 1000. Okay, so we're still using the same direction, but now we're multiplying that value by 1000. Let's save this and let's see how this works now. Okay, there we go. I can right click and you can see I can shoot out a cannonball in any direction that I'm looking at. Now, these are not being shot out super forcefully, but it's enough that we can actually see the difference. So you can continue to increase that force multiplier. And I think I'm going to stop right there in terms of shooting out these cannonballs. Let's take a look at one additional thing. This has nothing to do with physics, but if we are shooting out a bunch of these, I then want to dispose of them after a set time. So after 2 seconds, I can then say, hey, I want you to destroy this object and no longer have it in our scene. Go back into our code. Let's take a look at how we can modify that. Okay, going back into our code for the shoot cannonball, right now there is no restrictions on how many cannonballs I can fire. If I fire out 1000 cannonballs, that's going to slow down the performance of my game. So what I want to do in here is right when we create the clone, let's also register a physics collision to detect if we hit the ground. When we hit the ground, we can then start a 3-second timer to then dispose of the clone. So we're going to reference the ground. Right now, the ground is in the create imposters, but this is a local variable. I want to reference this in my separate method for the clones. So let's go up to the right top and let's create a variable for the ground as well. So we're going to call it ground and we're going to have a mesh type. At the very bottom of our create imposters, I'll say this.ground equals ground. Let's jump down into the shoot cannonball. And at the very bottom of this method, we're going to register a physics collision. I'll say clone.physicsImposter.register on physics collide. And this time I'm looking for the ground. So I'm going to say this.ground.physicsImposter. Okay, we're just checking for that one object. And then we're going to pass in a function, but we're going to do this in line. I'm not going to create a separate method for this. I'll create an arrow function. And within here, we're going to have a set timeout. Okay. I'm going to pass in an arrow function in there. And we're going to say after 3 seconds. So a timeout of 3000 milliseconds will equal 3 seconds. And what do we want to do in here? We want to say clone.dispose, and that's it. All right, so once again, whenever we hit the ground, so the physics imposter of the ground, we're going to have a timeout after 3 seconds to dispose of that clone. Let's see how this works in our scene. All right, let's fire off a couple of these cannonballs. After 3 seconds, they'll disappear. Okay, so now we no longer have a bunch of cannonballs that are just sitting in our game. Now, if you really want to use a bunch of these cannonballs over and over again, you can use something called object pooling. That's something we'll take a look at in a future video, but this will allow you to reuse the same objects over and over again. Okay, so there you have it. Now you understand how to create an impulse and apply forces to objects in BabylonJS.